Let's continue our work with solving quadratics with this portion of the worksheet where we're going to use the quadratic formula. And remember, the quadratic formula can be used on any of these quadratics. But one thing we have to make sure is our quadratic is set equal to 0. It's set equal to 0 before we do anything. So if I'm using the quadratic formula, I must have it equal 0. It must be equal 0. I would have to take the 1 over on this side to have it equal to 0 before I could use the quadratic formula. All right, so let's work on that. So now that this guy is set equal 0, what you're going to do is you're just going to find and label the values for A, B, and C. This is in the standard form with the square first, the middle term with the x, and the constant last. A is always the number in front of the x squared, so A is the number 1. There are no x's on A. It is just the value of 1. B is our middle term, and it's the coefficient in front of x. It's a positive 3, but I'll just write it as 3. And C is that constant value. It's a positive 2, and I'm just going to write it as 2. Once you have identified A, B, and C, all you have to do is sprinkle in those values in these positions in the quadratic formula. Then you've got to be careful when you do the simplifying. So let's put in the values. So I'm going to write the formula. It says it's negative B, so it's going to be negative 3 plus or minus. Under the square root, it says it's B squared. So that's going to be 3 squared, which is 9, minus 4, times A, which is 1, times C, which is 2. And this is all over 2 times A, which is 1. Now that we have all the values in play, we need to do some arithmetic to clean this up. I've got negative 3 plus or minus. What do we end up with under that radical? Well, I end up with 9 minus 4 times 1 times 2. Remember, you always do the multiplications first before you do additions or subtractions. So this will be 9 minus 8. And 9 minus 8 is just 1. The denominator, 2 times 1, which is 2. Notice what happens with this guy. The radical is going to actually go away. And that's because this problem originally factored. All right, so forget about that for now. Let's just clean this up. The square root of 1 is just the number 1. So what I'm looking at is negative 3 plus or minus 1 all over 2. And if I break those down, I have negative 3 plus 1 over 2 and negative 3 minus 1 over 2. I'm finding my two answers. Plus or minus gives me two answers. I broke this into two parts. Negative 3 plus 1 over 2, negative 3 minus 1 over 2, and that will give me my two answers. This is going to end up being negative 2 over 2, which is negative 1. This is negative 4 over 2, which is negative 2. My two answers are negative 1 and negative 2. And when your answers end up with no radicals left in them, then that means that problem originally factored. And if you ask me, factoring that thing would have been a lot easier than going through this. But I just want you to realize, if it factors, you can use the quadratic formula. For problem 13, it's already set equal to 0. So all I need to do is to pick my values of A, B, and C. And A is the coefficient on x squared, so A would be 1. B is the coefficient on the x term, which would be a positive 8. I'm just going to write that as an 8. And notice this problem does not have the C. Like this had a 2, this problem does not have C, so it's going to be 0. So when you go to plug in your values in your quadratic formula, you're going to plug a 0 in place for C. Notice number 13 is like we did above. It's a factoring problem. All you'd have to do would be to factor out the 8 on these factor out the x, and you could very easily solve it as x times x plus 8. But I want to illustrate that the quadratic formula also works for this. So negative b would be negative 8, just using this formula, plus or minus the square root. B squared will be 8 squared, which is 64, minus 4 times a, which is 1, times c, which is 0. And that's all over 2 times a, which is 2 times 1. So I end up with a negative 8, plus or minus. The back part of this is a negative 4 times 1 times 0. Anything times 0 is 0, so I'm just left with 64 under the radical. This is going to break up, and notice 64 is a perfect square. So I have negative 8 plus or minus 8. Oops, I put a 20 on the bottom. That should have just been 2. Negative 8 plus or minus 8 over 2. If you break that down, you will end up with 2 answers, one of 0 and one of negative 8. Again, these 2 answers come from breaking that result up, breaking up this result, just like we did over here, into 2 parts. Negative 8 plus 8 would be 0 over 2, which is 0. Negative 8 minus 8 would be negative 16 over 2, which is negative 8. We just worked some problems using the quadratic formula, so I want to go down to this problem number 24 to explain to you some common mistakes when using the quadratic formula. Remember, you can use the quadratic when your problem is set equals 0, and this one is. Hooray! Then we have to grab the values of a, b, and c. A is on the x term, which is the coefficient, just the 2. B is the coefficient on the middle term, which in this case is a negative 1, understood 1. And c is that constant on the end. So these are my values of a, b, and c. Now, let's see what mistakes were made when putting those into the quadratic formula. And remember, the formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Actually, I would like you to pause the video. I would like you to put the values of a, b, and c into this formula. Compare what you get to this guy that has mistakes and see if you can find the mistakes. So pause the video and try it on your own. Did you find the mistake they made? Well, I put all these values, a, b, and c, into play in my quadratic formula. I came up with this, and so I noticed that, and darn, let me move this for a second. Let me grab a little reddish here and back that. Oh, come on, there we go. I find right here a mistake was made because this is what I got. The formula says negative b, and since b is already negative, we have to do a negative 1. That's a mistake right there. That turns into a positive 1. The negative 1 squared is good. The minus, the 4, the 2. Oops, they made a mistake right there because c is a negative 6 and they plugged in a positive 6. There's our second mistake. That should be a negative 6. 2 very common mistakes that are made when using the quadratic formula. Now, take a minute and work through the end result of that quadratic. Okay, so we found 2 mistakes, the negative 1 in front, the 6 underneath. We have our setup correctly, and if you go through the process of simplifying that expression, the negative 1 squared is a positive 1 under the radical. The negative 1 is a positive 1 up front. And the negative 4 times the 2 times the negative 6 gives me a positive 48. You've got to be real careful with your signs. Well, 1 plus 48 is 49 under the radical, and 49 is a perfect square, which gives me 7. Square root of 49 is 7. That tells me the original problem did factor. When the radical goes away, that guy was factorable. Anyway, we'll split this up into two answers, 1 plus 7 over 4 and 1 minus 7 over 4 to give us an answer of 2 and an answer of negative 3/2. So now when you're confronted with solve a quadratic, you've got to pick a method that's going to work. So for these problems, it says solve each equation any way you want. So when you come across a problem and you see that he's already set equals 0, then, and you have your 3 terms on the left, I might start by factoring. Or I could start with the quadratic formula. Those are my choices here. I notice this quadratic is not equal to 0, and I need to set him equal to 0 to work on it. So I would need to take that 15 over, subtract it on each side, and I would get a 1 minus 15, which would be a negative 14. Once he's set equals 0, then I have a choice. I can factor. It has these 3 terms. That tells me I would want to factor or use the quadratic formula. This guy's already set equals 0, so I would try to factor or use the quadratic formula. This is set up for me to use the square root method because I have something squared equal to a number. And when it's in that format, you can use the square root method. So let's actually work this one out. Something squared equal to a number. I'm going to square root both sides. Can't forget to put in my plus or minus. And when I square root the x plus 2 squared, remember square rooting the square causes it to cancel, and I'm just left with x plus 2. Nice. The right-hand side, square root of 36, is just 6. So I'm just left with plus or minus 6. To find my final values, I'm going to subtract the 2, and so I'll end up with negative 2 plus or minus 6. Or you could have wrote that as plus or minus 6 minus 2. Either way, you'll get 2 answers. Negative 2 plus 6 is what? 4. Negative 2 minus 6 is what? Negative 8. 2 answers. This is a really nice problem. This guy, 3 terms, set equals 0. I would factor or use the quadratic formula. This one, 3 terms, he set equals 0. Factor or use the quadratic formula. These guys here, he set equals 0. 3 terms, factor or use the quadratic formula. 3 terms equals 0. I would factor or use the quadratic formula. Notice number 20, he's one of those easy guys because it's something squared equal to a number. And when that's the case, all you have to do is drop a square root on both sides, not forgetting the plus or minus. The square and the square root cancels, and I get a plus or minus 6 as my 2 answers. I suggest that you work through all the problems on here that I did not solve for you to get some practice on solving these quadratic equations. So you've got a few here to fill in, and if you've got any questions or if you want to know what the final answer is on any of these, either send me an email or I'll probably give you the final solutions and I'll probably just email it to you. Anyway, good luck with this. Let me know if you have any questions.